Hi, everyone. I just wanted to clarify this example right here that I kind of punted on in the middle and then and ended up correcting myself. I just want to make sure that this is clear what's happening because I sort of I sort of botched the overall message, I think, and I don't want that to happen. This is already a hard enough medium to deal with, and I want to make sure stuff is clear. Okay, so this problem was we had telephone calls arriving 2 every 3 minutes. Now, when you have a situation like this, you do need to identify what your time unit is. And you could work in chunks of 3 and have that be your unit, but that's just kind of weird, okay? So, because every time you would write 1, you would be thinking of that as actually being 3 minutes. And who wants to do that? Okay, so you kind of identify your unit of time, and that's a minute. Okay, so if 2 are arriving every 3 minutes, then that means every minute. So per minute, you're having like 2/3 of a call, which is kind of weird, but that's what you have to do in order to get this to work out, or in order to kind of describe this effectively using the Poisson process and the gamma distribution. Okay, so here is the setup. Let me see here. I'm going to share this screen with you. Okay, so here we go. Here it comes. 3, 2, 1. Let's do this. Okay, so how does this work? Well, x, which is the number or the length of time. Okay, so let me just kind of write this. X, this thing is, so x equals length of time until the second observation. Okay, and because we talk about a length of time, we need units in which to speak. And if I really wanted to use 3 minutes as my unit interval, then then x would have to be like, if x was equal to 1 or something like that, or if x was equal to 2, those would be 2 units of 3 minutes, and that's just confusing. So length of time, let's actually say that this length of time is in minutes. Okay, so this is in minutes. Okay, and therefore I need to talk about everything in terms of minutes. So x is distributed as, right, since we're waiting for the second observation, x is distributed as a gamma with alpha equal to, okay, so what is it? 2 observations. That's the number of observations I am waiting for. Okay, lambda in this Poisson process. So what is this? So lambda is equal to the expected number of observations per minute, right? So in other words, lambda is equal to 2/3 observations per minute. Okay, this is observations per minute. So what is beta? Beta is equal to 1 over lambda, and that's just going to flip these units. Okay, so this is 3 over 2 minutes per observation. That means that, I'm expecting to have to wait 3 over 2 minutes per observation. So that's what beta is. Okay, so beta is equal to 3 over 2 minutes per observation. Minutes per observation. Okay, so that's what x is. And of course, then it's no surprise that the expected value of x is alpha beta. Okay, so think about that. Observations, minutes per observation. If I multiply those two things together, right? So alpha is equal to, right? So this is alpha observations. That's how many I'm waiting for. And then I multiply by beta minutes per observation. Okay, what am I going to get? What are my units going to be? So it's going to be alpha, beta, what? The observation units cancel, and I end up with minutes. Okay, so these units right here are in minutes. Okay, this is in minutes. That's the expected number of minutes the expected number of minutes I'm going to have to wait in order to observe 2. And of course, alpha times beta in this case ends up being 3. And that 3 is, of course, minutes. Okay, minutes. 3 minutes. Okay, so that's a fairly complete explanation of that, like what's going on with alpha and beta. It kind of helps explain some of the nuances that perhaps were a little bit muddled before, because I initially was treating a 3-minute unit of time as 1 unit. Okay, and that kind of muddied the waters a little bit. I would have to change how I was talking about X if I was going to do it that way. Okay, so what that means is, okay, let me share this thing right here that we were looking at before. Okay, so this is all correct. If I wanted the probability that X is greater than 2, if I wanted the probability that X was greater than 2, then I do 1 minus, that's what this is, 1 minus the gamma distribution. What is this? X is 2, alpha is 2, beta is 3/2. I want the cumulative, yes. And I hit enter and I get 0.61506, right? So X is indeed distributed as a gamma with alpha equal to 2 observations. That's what I'm waiting for. And beta equal to 3/2 minutes per observation, 1.5 minutes for every observation. Okay? That is all I wanted to say. I'm going to leave it at this for today's lecture. I think we're in a good place. We'll finish up with the normal distribution next time, and then we'll move on to some other topics for Friday. All right, bye for now.